Hello my dear brothers and sisters. So we'll be discussing about binary tree today and some of the properties of the binary tree, right? So that is the agenda for today's video. So let's start with this. Before starting, if you are new to this particular channel, so please don't forget to subscribe and press the bell icon so that we'll get notified whenever new video is coming. And this also motivates me to create such videos, right? So let's continue with the binary tree. So what is a binary tree? So as its name suggests, right? What is binary? That means there are two, right? So whenever either 0, 1, right? So there are two children. Binary means two, right? So binary tree is a tree in which each node have at most two children, right? So that means every node, if you look into this or any node you look into that tree, then it can have maximum how many children? It can have at most two children. For example, is this a binary tree? Yes, it is a binary tree. So is it a binary tree? Answer is no, it is not a binary tree. Why? Because this particular node, if you look into this particular node, which is violating the properties of binary tree. So that's why if I add one more extra node into this particular tree, like I have added here, so then this is not a binary tree. So if you talk about is it a binary tree? Is it a binary tree? Answer is yes, it is a binary tree. Why? Because the condition is that any node can have maximum two children. So that means any node can have zero child or one child or two child, right? So that is the principle. So if you look into this tree, so this node has one child, one child, one child, one child, zero child, right? So it is lies between 0 to 2. But if you look into this, so this is having two child, so this node is satisfying, this node is 0, so this node is 2. But this node is have how many children? So this node have 3 children. So that's why this node is not satisfying. That's why this is not a binary tree, right? So binary tree means, let me repeat the same sentence. It is a tree which has any node, right? It is not like that only one node is satisfying, then we are good, right? It is any node have at almost two children, right? If any one of the node is not satisfying the binary tree condition, that means if they do not have two children, then we can happily say that that tree is not a binary tree. So by this time you might have realized, so what is a binary tree? So binary tree is a tree. So then every node can have at most, right? So maximum two children. So if you look into this particular thing, so is it a binary tree now after removing this particular node? Answer is yes, because every node can have maximum two children, right? Okay, so and binary tree is an important concept, right? Because it has a lot of applications and a lot of lead code problem if you want to solve. So this is a right data structure. And there is a lot of problem we are going to solve on this. So let's jump into the properties. Properties number one, right? So what is the maximum number of nodes possible at any level, right? Just try to understand this very carefully, right? I'll read one more time. Maximum number of node possible at any level, right? So these are levels, right? So these are levels, right? So if you remember, so what is the maximum number of node is possible in any of the level, right? Suppose if we'll talk about, so this is level 0, right? So if it is level 0, level 1, level 2, suppose I'll ask, okay, what is the maximum number of node, right, is possible at level 2, right, for example. So let's try to understand that and try to draw the tree, right? So suppose, let me ask you, how many maximum number of nodes possible with the level 0, right? It can be only one node, right? Because we know that every tree will have at most or only one particular root node. So that's why level 0 will always have how many node? That is one node. So if I ask the same question, right? So maximum number possible at level 2 or maybe level 1, right? So if I'll ask what is the maximum number of node? So how many maximum nodes can have any node, right? So this is a tree node. Can I have 3 nodes? No, because it is a binary tree. It can have maximum 2 nodes, right? So that's why the maximum number of node that is possible at level 1 is 2. Now let me ask one more question. What is the maximum number of nodes that can be possible at level 2, right? So this is 2, but if I'm talking about the maximum number of nodes, so then I can have, actually there are 2 more nodes here, right? So this is the maximum node. So how many nodes I can have in this particular level? So this level I can have 1, 2, 3, 4, right? So do you see a pattern now, right? So do you see a pattern that how many number of nodes, right? So let me jump into maybe level 3 so that you will get more clarity. Maximum number of nodes means every node will have two children, right? So that is the maximum possibility, right? So that is the maximum. So how many nodes are available in this node? If you count 1, 2, 3, 4, 5, 6, 7, 8. So 8 number of nodes, right? So do you see a pattern now, right? If I ask you now, suppose ith level, right? So ith level, right? So like it was third L equal to I, right? So ith level, right? Any generic level. So what is the maximum number of nodes present in the ith level? So you can see, right? So it is actually in the format. What is the format? This is 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3. Likewise, it is going on, right? So then what you can say, if it is ith level, so then how many number of nodes that maximum can have? Then 2 to the power I number of nodes, right? Number of nodes, right? I hope it is making sense. So basically, if somebody asks you what is the maximum number of node possible at any level, level I suppose, level I, right? Suppose level I. So then you can say what could be the answer? It is 2 to the power I, right? So that is the answer. I hope it is making sense, 2 to the power I. So that is the answer. Okay. So this is the explanation for that, right? So now let's jump into the question number 2. Can any node have three children? In a binary tree? So this is very simple answer. Answer is no, right? Because it is a binary tree. So that's why the simple answer is no. Any node cannot have three child. If this is a three child, if you add three childs to any particular node, so then it is no more a binary tree, right? So that is the explanation. Okay, so this one is done. So number 1, number 2 is done. Let's jump into the third one. This is an interesting one. Minimum number of nodes in a tree of height h, right? So what is the minimum number? So we are given a height h tree, right? So height h, let's say, suppose let's take a height equal to 3. So we are given a height of 3, right? 3, right? So this is my tree, right? So this is a binary tree. So height is how much? Height is 3, right? Height is 3, right? So because this is 0, right? This is 1, this is 2, this is 3, right? So the height is 3, right? Height is 3. Okay. So sorry, it will be actually determined from the below. So 0, 1, 2, 3, right? So that is why. But height is 3. But anyway, so that will be the depth. Okay. So since this is the height of 3, so where h is equal to height equal to 3, then what is the minimum number of nodes possible, right? If a height is 3, what is the minimum number of nodes? So can I remove, try to understand, right? So can I remove this node, right? And still is it going to be, height is going to be 3? Can I remove this, right? So height is going to be 3, yes. Can I remove this also? The height is going to be 3. Can I remove this? Yes, I can remove. So is this a binary tree now? Can I remove something else but still it is going to be a binary tree? Can I remove this? If I remove this, then this is still not a tree, right? Because this is going to be disconnected. So how many nodes? If we'll think, so this could be one possible answer, right? So if we'll think, so this could be one possible answer, or there is other possible. So in this case, so this could be the minimum number. How many minimum number of nodes? If we'll see, this is the 1, 2, 3, 4, right? So that means what? So that means if you are given a height h, so then minimum number of nodes is needed in order to create that height h tree, binary tree, is h plus 1, right? H plus 1, right? I hope it is making sense, right? Minimum number of nodes in a tree of height h. So minimum is how much? Minimum h plus 1 if you are giving, then you can construct a tree of height h, right? So let's jump into the next problem, right? So let's jump into the next problem, right? So let's jump into the next problem. So which is like minimum number of node of, I think this should be maximum. So let's do it maximum. Sorry. So this is the maximum number of node, right? So this is the maximum number of node in a tree of height h, right? So this we discussed. So this was the minimum number of node. Now the question is that what is the maximum number of node possible, right? So basically what is the maximum number means everybody are fully, completely allocated, right? So that means everybody have two childrens. So that's how you will be able to do this, right? I hope you are getting it, right? So everybody will have two children. So that's how you can maximize the number of nodes. And this is going to be the height of the tree. Let's try to do this analogy, right? So let's understand this, right? So let's take this particular tree maybe and then understand. So let's say that, okay, you are given a height 0. Then how many number of nodes? So it is going to be 0 node, right? So then now let's talk about if the height or the, then if you are given suppose only one node, right? So this is my tree. So this is my tree. Then this is height is how much? Height is 0. Then how many number of nodes is there? Number of nodes is 1. Suppose now the number of, so you are given a, what is the height is 2. Suppose you are given is height is 1. Suppose height is 1 means this is the maximum number of node possible. So if the height is 1, so how many number of nodes is there? Height is 1 means number of node is 3, right? So this is the number of node, right? Now let me take height is equal to 2. What is the maximum number of nodes possible? Height equal to 2. So this is the height equal to 2, right? So what is the maximum number of nodes possible? So it is going to be 1 plus 2 plus 4, right? Which is 7. Just try to understand. So this is going to be 1, this is going to be 2, this is going to be 3, right? So you know, if I take height equal to 3, so then how much it is going to be? So this one is the height equal to 3, right? That means 1, 1, 1 plus 2 plus, sorry, so this should be 4, right? Yeah, 4 plus 3 is equal to 7. So 1 plus 2 plus 4 plus then next level will be 8, right? So this is how you will continue. So can you now formulate this one into some formula, right? So let's understand. So how it goes on. So it is basically 2 to the power 0. So if you realize 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3, right? So that means if height is 3, so what, how much exactly? So let's talk about this one, right? So which is the simpler to calculate. So if height is 3, height is 2, so then it is going to be 7, right? So that means what? So it is going to be 1 plus 2 plus 3, right? Which is 7. 1 plus 2 plus 4, right? Which is 7. So can I say, so think about this way. So it is going to be 2 to the power. So if h plus 1 minus 1, right? So this is the formula. So that means let's think about this, right? So what is the number of nodes is present in the next level, right? Maximum number. So maximum number is 8, right? Suppose this was the 4, then maximum number of nodes is going to be 8, right? So maximum number is going to be 8. If it is going to be 8, then this tree, which is the before that, is always going to be 7 node, right? For example, so if this is the 8 number of nodes is present, then whole tree, this is also another observation, important observation, will be whatever node present is in this particular thing. So then this is going to be minus 1. If there are 8 number of nodes, so that means all total nodes is going to be how much? It is going to be 7, right? Okay. So that's why this is going to be 2 to the power h plus 1, right? Minus 1. So 2 to the power h plus 1 means next level nodes, right? So that is the number of nodes present in the next level. So minus 1, right? So like 8 minus 1 is 7. So this is going to be how much then? So this is going to be 2 to the power 4 minus 1, right? So which is going to be 16 minus 1, which is going to be 15, right? 15, right? Similar way, next level. So if there is a next level, so which is h equal to 4, so then how many number of nodes is present? So then this is going to be 2 to the power 5 minus 1, right? So which is 32 minus 1, which is going to be 31. So this is the number of nodes, maximum number of nodes that is present in an tree of height h, right? So how, what is the formula? 2 to the power h plus 1, right? Minus 1. Minus 1 is like below, right? So this is important, not in above. So this is the formula. Okay. And we discussed these things. Now let's look into the number 5. If number of nodes is minimum, so this is an important observation, right? So this is nothing to derive. If the number of nodes is minimum, then height of the tree is the maximum. If the number of nodes is minimum, then height is maximum, right? Like we discussed, right? So if the number of, like let's take an example, maybe we'll be able to very clearly understand, but it is simple, right? So if the number of nodes is minimum, so this is the minimum node, so then the height is maximum, right? So that's what it is saying. If the number of nodes is minimum, then the height of the tree is maximum, and vice versa. If the number of nodes are maximum, then height is also minimum, right? You cannot create, if there are maximum number of nodes, so you cannot create a height which is less than that node, right? So that is what an observation. So look into this number 6 and 7, which are related. So what does this says? Maximum height of a tree, right, with n nodes, right? So this is an important observation, important also. So let's look into this. Maximum height of a tree with n nodes. What does that says? Okay, so we are given n nodes, right? N nodes. So what it is saying? So what is the height of the tree, right? Maximum height. So it is asking maximum height. maximum height. Okay, so if like number of nodes is given given n, right? So what is the maximum height? So if you think, how can we actually derive the maximum height? If you remember, so this is the maximum height, right? If there are 4 nodes, can I, if there are 1 2 3 4 nodes, can I have more height? No, right? So that means what? So maximum height is only possible then every child has only one child, right? Except this is the leaf node, but everyone will be like below. If I, instead of this, if I do this, so then this is not going to be maybe maximum height, right? Height will be 2. So that's why, so this is the one possibility. So that's why if height of the tree is like 3, right? So if the number of nodes, so how can you say number of nodes? So then equal to height minus 1. So if there are 4 nodes, right? So what is the height? Height is 3, right? So there are 4 nodes, suppose, right? So height is 3, right? Height is 3 because this is 0 1 2 3. So this is how the height is calculated, right? So if I add one more node, so which is the 5 node, then what is the height? Height just incremented by 1, then it is going to be 4. So that's why this is the formula, right? So n equal to h minus 1. So then what is the height? We are asked, right? So what is the maximum height of the tree? Then height you can compute as h equal to n minus 1. Okay, so this is how the height can be computed. So what is the maximum number of height with a node? So this is going to be h equal to n minus 1. Okay, now let's look into the number 7, right? So which is the minimum number of minimum height, right? So that's what they are asking, minimum height. So how to compute that particular minimum height? You already know this, right? So because when exactly the minimum height will be formulated, when there is a when there is all nodes are full kind of thing, right? So like this is the minimum height, right? Minimum height with n node, right? Then you remember the formula. So what was the formula? Number of nodes equal to 2 to the power h plus 1 minus 1. This was the number of node formula, right? Whenever the height is maximum. So you can simply like find what is the height, right? So what I can do, so 2 to the power h plus 1 equal to n plus 1. That's what we can do because we are interested finding the height. So what I can do, right? So 2 to the power h plus 1 equal to this. Now I can take the log of base 2 both side, right? If I take log, so base 2, so then this got cancelled. So this is going to be h plus 1. So because, so this is log base 2 n plus 1, right? So this is how it will be. Then what will be the height? Height is going to be log 2 n plus 1 minus 1, right? So this is the height of the tree. So what is the minimum height of a tree with n nodes, right? What is the minimum height? So this is the height formula. So this is the log 2 n plus 1 minus 1. So these are the some of the properties. I hope you liked the video. In case you have any further queries, please put it in the comment box. I'll definitely going to answer it. And so again, so I'll in case you have not still subscribed, please subscribe to my channel and see you in the next class. Thank you so much for watching. Bye. Take care.